So next up is the multiplying radicals. And again, we have some fill in the blanks. So I filled those in already to save time with the video. All you're going to do is pause the video now so that you can copy what I've written, and I'll refer to that as we go along with the video. So please, for now, just pause the video. So zooming in here, I have these steps. We can multiply radicals if they have the same index. Okay. What that means is that if we look at this one here, it doesn't matter that 12 and 15 are different. We can still multiply these together. Okay. If this was the square root of 12 and the third root of 15, then we couldn't, because square root and third root are very different things. Okay, but just because the 12 and the 15 are different doesn't mean that we can't multiply them. So the steps for multiplying are actually pretty simple. The first step is to multiply the numbers outside of the radical symbol. So we look at this one, there's no number outside here and no number outside here, so we actually skip step 1. And we go to step 2. Step 2 says multiply the numbers inside the radical. So the square root of 3 times the square root of 3 turns into the square root of 3 times 3. Okay, I just put them both into a square root symbol. And the square root of 3 times the square root of 3 is, well, 3 times 3 is 9. And the square root of 9 is 3. So it doesn't get much easier than that, right? Now step it up a little bit here. We do have to do step 1. We have 2 square root 12 times 4 square root 15. And so we're multiplying the numbers outside the radicals first. That means I'm going to do 2 times 4 on the outside. And then I multiply the numbers inside the radical, so it becomes 12 times 15. So it's 2 times 4, square root 12 times 15. And now I've got to simplify that. Well, I could multiply 12 and 15 and get kind of a big number, but what I could also do is find the prime factorization of each of these, and that'll be a shorter process if I have smaller numbers. So I'll start with 12. Prime number goes to 12 is 3. Division with 4. Then I have 2. Division with 2. And 2 gives me my candle. Prime factorization of 15. I've got 3. And then I've got 5. Okay, so there's my candle. And what I'm left with is now 2 times 4 times the square root of 2 times 2 times 3. There's my 12. And then 3 times 5. That's my 15. Okay? And so if I were to do 12 times 15 and then find the prime factorization of that, what you'd see is it would be 2, 2, 3, 3, and 5. Okay, so I'm not really changing anything. I'm just making it less work. Okay. Now, multiply numbers outside the radical. I can actually simplify that right now. 2 times 4 is 8. Okay. And I've multiplied numbers on the inside of the radical. Now I just have to circle groups of 2 to bring out. So we've got a 2 here. And I have a group of 3's. And then left over is the square root of 5. And then I can do 8 times 2 times 3. 8 times 2 is 16. Times 3 is 48. So that's 48 times the square root of 5. Okay, so if I've got bigger numbers, it becomes a lengthier process, but really we're just following the steps doing multiplication and then finding the prime factorization. Our next example is still sticking with multiplication, but now we have to distribute because we have these grouping symbols here. So I'm distributing in the square root of 3. So I've got the square root of 3 times 3, which would simply give me 3 square root of 3. It would be like saying square root of 3 times x. I just put the x on the outside. And then I've got the square root of 3 times the square root of 6. So I'm adding square root of 3 times the square root of 6. And I'll just keep going with that. So I have 3 square root of 3. There's nothing I can do to simplify that. And the square root of 3 times the square root of 6 is the square root of 3 times 6. Right. And I keep going. Prime factorization of 6 is 3 times 2, so I've got 3 times 3 times 2. I'll just kind of circle that out of the way. So that's 3 square root of 3 plus, and now simplifying square roots, I can take out this 3 and I'm left with 3 square root 2. And that's all I can do. I can't add those ones together because they have different radicals, right? The square root of 3 and the square root of 2 are very different, so I can't combine them. Okay. This last example here is actually going to be an exceeding expectations problem. And you haven't seen something like this before where we have 2 terms multiplied by 2 terms. And it is a form of distribution. It's called double distribution. So what I will do is I'll break it up for you, and if you would like me to show you how to do it, I can come over and do that. So double distribution means that first I'm going to distribute in the 3 to everything in the parentheses. And then I would distribute the square root of 3 to everything in the parentheses. And you would keep going from there, right? Distribute in the 3, distribute in the square root of 3, and then see what you can add together. If you want me to check your answer as you try this problem out, please feel free to do so. If you want me to come over and do it with you, I can do that too. But the next step for you is to do problems 3 and 4 on your practice, on the left side for practice. It's 3 square root 12 times the square root of 6. And then number 4 is the square root of 3 times the quantity square root 6 plus square root 75. And when you're done with that, you're going to show your teacher, and he or she will check your answer.